All right, guys, so this is going to be the last lesson of exponentials, actually, if you believe it or not. We're going to actually just look at solving some word problems and then move on from there, okay? So what we actually want to do is take the equations that we've looked at in, or the ideas in lesson 4 with the investigation, and we're going to actually apply them to actual word problems now, okay? So some of the success criteria around that is going to be able to, or being able to model word problems with an exponential equation, right? So just like quadratics, we had to come up with two binomial pieces that represented two different things in a question. Then we multiplied them together and created a trinomial that we could either factor or complete the square on in order to actually answer the question, right? And then being able to solve the resulting exponential equation, which I showed you how to actually solve some of these, okay? So let's just, there's a lot of text here, okay? So properties of exponential growth, okay? So as the independent variable, okay? So that's the x-axis, right? As that variable increases by a constant amount, the dependent variable increases by a common factor, right? So what that ends up doing is it creates this curve, right? So it's increasing by a common factor each time. So it's getting two times bigger, and it creates what we call this exponential growth, okay? The graph increases at an increasing rate, okay? In exponential growth, the rate of change increases over time, okay? So it's continually getting bigger and bigger, okay? So in other words, it says the rate of growth becomes faster as time passes, okay? With properties of exponential decay, it's very similar in the sense that, well, it's virtually identical, except this time we're decaying, so we're losing whatever it is, right? If it's a population or if we're losing money and exponentially, right? So it's decreasing by a common factor this time, right? The graph is decreasing at a decreasing rate. And exponential decay, the rate of change decreases over time, okay? So it's virtually identical to exponential growth with the exception of this time, the curve this time, right? Where as the independent variable increases, x, right? Our graph is going to do something like this. It's going to approach the x-axis as time goes on. So that's exponential decay, okay? And there's a few different kinds of problems that you're going to see, okay? So I'm going to highlight some stuff here for you, okay? R represents the percent or the rate at which a quantity increases or decreases, okay? Now, the sticky point, and this is the thing that everybody messes up on, is that R must be converted to a decimal, okay? That's very important before substituting into the formula, okay? So we cannot plug in things like 100%. We cannot type that in, or we cannot type in, if the question says it increases by, I don't know, 5%, we cannot type in 5%. That will give us some extraordinarily wrong answer. We have to plug in 0.05, okay? That's important, okay? And then we denote starting amounts or initial amounts at time equals 0 with what we call this m naught or m naught, right? So the initial value, okay? So you start seeing those appearing here, okay? Okay, so these are just the 4 equations that you're going to need to use in order to answer any exponential growth or decay question, okay? And then they're labeled here for you too nicely, okay? So population growth or appreciation with financials, okay, is you're going to have some starting amount. So if I'm interested in some amount after some conditions, right? So something's increasing by some rate, okay, which we discussed up here, okay? So if something's going to increase by some R value, that's going to get plugged into the equation as a decimal, okay? And then you're also going to have some initial value, right? So what are you starting with? Okay, that's going to be n naught, okay? And the last part of this is a very straightforward equation, okay, is time. How long is something being invested for? How long is environmental conditions being forced upon a population? Stuff like that, okay? And then you can see the only difference between growth and decline or decay would be the presence of this minus sign. Okay. Okay. And so then we have, these are a little bit, these can be applied to a broader scenario of questions relative to the two at the bottom, right? But a lot of the time you will see, particularly in science or in any kind of discussion, and maybe the media will discuss half-lives, or how long does it take for something to double or cut itself in half, right? So here are the two equations that correspond with this, very similar, okay? Here's where I'm like trying to answer some amount of something, right? Here's my initial value. It's going to double, okay? And then you have the two conditions in the exponent, okay? Which we'll discuss in an actual word problem so that it makes sense in context, okay? Okay, so let's take a look at the first example here, okay? So maybe the hardest part of doing some of these questions is being able to identify which of the four equations you would like to use, okay? This is looking kind of messy, so I'm just going to clean it up, okay? So that's basically the hardest thing, right? And you're looking for word indicators such as doubling, or half-life, or appreciates by some percentage, or depreciates by some percentage. You're looking for keywords that are going to help you select an equation, okay? And so let's take a look at the first question. So the population on Basel Island is currently 102 people, okay? I see a current condition, a starting point, right? So I'm going to say N naught is 102 people, okay? And naught, you'll see, appears in all of the equations, right? So I'm safe. I don't know which equation I'm using yet, okay? But that's my starting point, right? Now I'm seeing that there is a growing condition, right? So it's growing at 15%. Okay, but I'm just going to get you in the habit of changing that right away. I'm not going to leave it as percent. I'm going to change that as 0.15 so that when you go to plug this in, R is not equal to 15%. It's equal to 0.15. Okay. So you have to, this question is asking you to predict the population on the island 3 years from now. Okay, so you want a t value equals 3. Okay, so then you're going to go up to your equations and you're thinking, okay, which one am I going to pick, right? And that's kind of the challenge, right? Is what I was saying before. Okay. Let me just write one more thing here. I want to know N. That's what I want to know. What's the population going to be? Okay, so I'm going to go up here. It says in the question that it's growing at 15%. So I'm going to go up here and go to my growth or appreciation equation, which is right here. Okay, I'm going to delete all this stuff just to clean it up. Okay. So I'm going to go to this equation and I'm going to select it and I'm just going to write it down. T. And then all I'm going to do from here is plug in what I know. Okay, so I'm just going to go N is equal to, and naught we said was 102 multiplied by 1 plus R was 0.15. And then the T value is 3. Okay, so some of this is going to be a calculator exercise, okay? And you have to actually be careful with the order of your operations, right? So we've got to follow BEDMAS pretty closely here. Otherwise, we're going to get wrong answers, okay? So I did what was inside the brackets first, and now I'm going to apply the exponent. I don't have any division in this question, so I'm just going to multiply at the end, okay? So what I need to figure out is I got to go back to my calculator here, okay? And I need to do 1.15 because that's the 15% added to the original. That needs to go to the exponent cubed. So this guy right here, okay? 1.52, we'll call it, okay? So let's go back to here. So it's 102 multiplied by 1.52, okay? Okay, and then so the answer is going to be 1.52 multiplied by 102. 155. Okay, and then you could write a little therefore statement that said, therefore the pop 155 after 3 years. Okay, really pretty straightforward, okay, as long as you follow some mathematical basics, right? So following BEDMAS, and really, I always emphasize the importance of coming up with this list of knowns and unknowns, okay? Because that's really going to help you with not making a mistake, plugging things in, and remembering that the rate needs to be switched to a decimal, okay? So let's take a look at the next question. Okay, there's a whole bunch of examples here. I'll try to minimize the length at which you have to watch this video, okay? So, and we'll do as many questions as we possibly can, okay? So, in 1960, the frog population on Bosco Island was 5,000 and been doubling every 7 years, okay? So this is an example of every 7 years, the population is now at double what it was 7 years ago, okay? So, in other words, after 7 years, the population would have been 10,000 for this, just as a stating, just to clarify any issues, okay? So if this trend continues, write a formula for how the population will change starting in 1980, use t equals 0 in 1980, okay? So use this formula to find the frog population in 2002. Okay, so this is where I'm going to be able to emphasize the difference in this exponent here, okay? And I'll write down, I'm going to start the exact same way. I'm going to start my list of things, right? So I'm going to say, okay, what's my initial value? So n naught is going to be 5,000, right? And then the doubling factor, okay, that's actually the d value that you see there. You're going to put the number 7 there, okay? So this is what we call how long does it take to double, right? So the d value is going to equal 7, okay? If this trend continues, write a formula, okay? So I know what the equation, so ultimately we're going to try and figure out what the population is going to be in 2002, okay? So, and I know it's a doubling equation because it's talking about that, right? So it's this one, okay? So n is equal to n naught multiplied by 2, or the doubling factor, right? And then in the exponent, you still have to write down the t and the d. Well, what's the t? The t is going to be the difference between 2002 minus 1980. Okay? So that is 22. Okay? So that's what's going to go in for t. Okay? And now you have everything. So you're just going to be able to do the math on this. I'm going to move this over to save some space. I'll draw a line. Okay? This is your list of knowns and unknowns, right? And you're ultimately trying to find n. You don't know. Okay? So let's plug stuff in. N is going to be equal to n naught, which is the 5,000 multiplied by 2, and then I'm going to have 22 divided by 7. Okay? Now, when I'm doing this question, if I cannot figure out, I need to figure out what this is as a nice kind of number, right? Because I don't really want to type this in as 2 to the exponent of 22 over 7. I don't want to do that, right? So let's go to our calculator for a sec, okay? And we'll come up with just as a decimal, okay? So n is going to equal to 5,000 multiplied by 2, and then I'm going to do the math on 22 divided by 7, okay? And that's going to be the decimal that I use. Okay, so 22 divided by 7 is going to be 3.14. Okay, so that's as good. Okay, and then I have to go back here. I'm going to go 2 I got to take the base 2, and I got to raise it to the exponent. I'm going to use this button this time, the x to the power of y, if you're on your calculator, okay, of 3.14. Okay, so 8.81. Go back. So n is going to be equal to 5,000 multiplied by 8.81, okay? The 8.81 came from this right here, okay? That's the math on that. And then you're just going to do 8.81 multiplied by 5,000, right? So n, we're going to figure out what the population is it's going to be 8.81 multiplied by 5,000. What did I say the number was? 44,050. Okay. Then you could write down the therefore statement. Okay. Okay. Again, I think you're going to see some variances in your answers depending on how many decimals you decide to carry for your exponent. Okay. If you show your work, I'm going to be able to see what you did, and not writing a 2 or 3 here is not going to be the end of the world, right? If I can see your work, it's all good. Okay. So therefore, therefore statement, therefore after 22 years, the frog population will be 44,050 frogs. Okay. So let's go to the next question. Okay. I already know what the equation is just because of the wording in the very first statement here, right? So I can go, I'm going to make my list of knowns and unknowns, right? If you can continue reading. So if you bought a computer for $1,800 this year, okay, and not is 1,800, okay, R value is 40%, which converts to 0.4, okay, and then the t value is 5 years. So I see the word depreciates at the beginning of this question. I ultimately want to know what the computer is worth after some amount of time, in this case 5 years, right? So I want to know the amount of money it's worth after 5 years. So I'm going to go up, I look at my equations and I go, okay, it's not growing because it's depreciating this time. So I want to know, it doesn't even have to be, it's financial. Again, earlier I said things can depreciate in value, right? So I'm going to select the one that looks like the first one, but this time the only difference is I've got this minus sign in here, right? So it's depreciating, okay? So I can go down here and I'm going to write out that equation. So n is equal to n naught, okay, multiplied by 1 minus r this time to the power of t. Okay, and I'm just going to fill in the information. So n is equal to, n naught is 1,800 multiplied by 1 minus 0.4 to the power of 5. N is equal to 1,800 multiplied by 0.6 to the power of 5. Okay. Now I can go back to my calculator, do the math on that. So it's, what did I say, 0.6. Again, I'm going to have to use this button, the x to the y button, to the power of 5, 0.07776. Let's just see what happens if I use all those digits, okay? So I'm going to go 1,800 multiplied by, okay, because I already did the math on this, right? 0.07776. Okay, so again, just so this can be confusing, bouncing back and forth on the calculator, if you were to type this into your calculator, you should get this number, hopefully. Okay, and then you just do the math on that. So you're going to go 1,800. You're going to take this number that we found, multiply it by 1800. Wow. 139.97. So it looks like computers are a horrible investment if you're trying to make investments, right? So therefore, the computer will be worth $139.97 after 5 years. Okay? You can really start to see the real life application of exponentials in particular, right? Maybe even more so than quadratics, although things generally behave in the real world like in a quadratic manner, in particular physics things, right? Exponentials really start to hone in on the way things actually behave in the real world. You'll see exponentials everywhere, right? And you can see how some of these equations look pretty easy to use, right? The only hard part is let's figure out how or when to use some of these equations, okay? So radon is a radioactive element that has a half-life of 28 days, okay? So given a 150 gram sample of radon, okay, part A wants you to determine how many grams of radon are left after 20 days, okay? So let's do part A. So again, I see the half-life thing. I know I'm going to use this half-life equation, right? The one with the half in it. And they conveniently like to use half-life questions a lot of the time are going to have to deal with mass, right? And so I have some mass of radon initially, and I want to know how much is left after some amount of time if the half-life is whatever it is, right? So this is another scenario where I'm going to show you how to use this T over H, okay, where I didn't really stipulate it up here, but if you watch this question, you'll see how to actually plug them in, okay? So let's go back down here, okay? I need to write out how much M naught. So how much radon am I dealing with initially? So it's 150 grams, right? And then I want to determine, okay, well, the half-life is H, right? This is the half-life, 25 days. Okay. Now, the only other part of this is, if you recall the equation, and we're doing part A at the moment, okay, so the equation looks like M is like how much mass is left after some amount of time given a half-life, so M is equal to M naught multiplied by 1/2 to the exponent of T over H. Okay, so you found H. H is the half-life of 25 days. Now, part A is specifically asking about how much is left after 20 days. So that's going to be your T value. So T is going to be 20 days. Okay, and so we just plug stuff in, and I want to know mass is this. Okay, I don't know, right? So I'll move this over, save myself some space. Okay. Okay, so let's draw a line. So M is going to equal to 150 multiplied by 1/2. And we got to figure out the exponent. The exponent is going to work out nicely this time because the T value is 20 over 25. Okay. That's going to turn out to be 4/5, right? I could read, so 20 over 25 is going to equal to 4/5, right? 4 out of 5 would be equal to 8 out of 10, which would be equal to 0.8. Okay, so I can actually, that's an easy exponent this time. You can see how that, I could do that one in my head, right? So M is equal to 150 multiplied by 1/2 to the 0.8. Okay, so you're going to have to go back in your calculator. You're going to type in 0.5. And then again, I have to use the x or the y because I don't have a 0.8 exponent, obviously, right? So then I got to type in 0.8. It's going to give me that answer, 0.5743. Let's go back. Oops. 0.5743. Right? Now, in a real life, radon's like not a overly safe element, okay? A lot of the time you might find radon in people's basements, right? So they might choose to carry more significant figures, is what we will call it in science, right? In order to actually get as accurate of an answer as possible, okay? Because there could be lives at risk sometimes, right? And so that's what carrying more decimal places versus deleting some actually does for you, right? You're going to get rounding error is what we call it, right? So you're going to have to go on here now. I have the full decimal still saved here, which is good, right? So I'm going to go take that. I'm going to hit the X right away. You see it saves the answer there and multiply that by what our initial amount was, which was 150, right? Well, let's make sure that's actually it. Yes. So multiply by 150. So it's 86.15 grams left. Okay, so then I could write, okay, therefore, after 20 days, 86.15 grams of radon still exists. Okay, now let's take a look at part B, because part B is going to ask me to do something subtly different, okay? Determine how long it takes the sample of radon to decay to 30 grams. A little bit more difficult this time, okay? So this is where I'm going to pull on some of your solving exponential or solving for variables in exponents, okay? So nothing's going to change. We're still using the half-life equation, okay? But this time I'll do this question in different colors so you can see differently, okay? So M naught, you're still starting with the same 150 grams. Right? Except this time, part B is actually asking you about how long does it take to decrease to 30 grams. So the M value this time is going to be 30. So they're switching up. It's not such a straightforward question anymore in a linear way, right? Where I'm always solving for the thing on the left side. What I'm going to do now, right, is have to solve for either the T or the H. Well, turns out that you're still going to leave the half-life, because the half-life of radon is still 25 days, right? So the H is still 25, which means the only thing you have left to solve for is the T value, which is ultimately the amount of time, right? How long it takes is going to be time, right? You don't know. So let's write out the equation again, okay? But this time I'm going to fill in the information. So M naught is going to be, or sorry, let's do 30, right? 30 is M, is equal to 150 multiplied by the 1/2, and then you write in the exponent of, it's going to be T divided by 20. Okay, so this is where things get a little bit more tricky, okay? So we have a bit of a solving conundrum here in a minute, okay? So I want to get I'm going to try my best to get the T value by itself. Okay, just T. Okay, so I'm going to basically divide both sides by 150, right? So I can do that still, right? And then these cancel and this ends up over here. Okay, so I'm going to get, and then again, if you typed into your calculator 30 divided by 150, I'm just trying to save some space here, you're going to get 0.2, okay? So 0.2, I'll highlight that so you can see that's where that came from, right? That's the actual math on that. 0.2 is equal to 1/2 to the T over 20. Okay, now you're at the stage where you're like, I don't know what's going on, right? And that's pretty common, actually, I would say, right? You could even, if you didn't like the decimal there, you could even leave this as being, it might be easier, actually, now that I've done this for the second time, teaching this particular lesson. 30 over 50 is going to be the same thing as 1/5. Right? I could reduce that fraction. Right? So here is your conundrum. Okay, if you think back to it would be lesson 5, right? So you're looking at the solving for variables and exponents. That's exactly what I got going on right here. Solving for a variable in an exponent, okay? Your job, okay, if you remember, in order to do anything, right, was to make, you need to make the bases match, okay? And because the exponent or the variable that you're trying to solve for is in the exponent on this side, right, with the 1/2, your job is going to be to figure out, and this is the tricky part, what do I need to raise this exponent to, okay, in order to give me 1/2. Okay, because ultimately I need the bases to match. Once the bases match, I can make the exponents equal to each other and I can just solve for t. Okay, but the first thing is I need to make the 1/5 into a 1/2. Okay, so this is basically like a trial and error thing. I don't have a good method for you, and you're not going to learn a good method until you take grade 12 functions, okay? Or grade 12 math, maybe, okay? Grade 12 functions for sure, okay? So your job is just to go to your calculator, and you're going to try to get, okay, this is a complete trial and error thing, right? You're going to go 1 divided by 5, you're going to need it as the decimal, so it's 0.2. You have to figure out, I'm going to hit x to the y, you have to figure out what do I have to put this decimal to the power of something, to give me 1/2. So let's just try 5 arbitrarily. Okay, it got really small. So it got smaller, so I'm moving in the wrong direction, okay? So now I go back, 0.2. Let's put it to the exponent of 0.5. Okay, closer. Okay, I need it to be 0.5. You're trying to get as close as you possibly can. Okay, well, let's go 0.5 to the exponent let's just cut it in half, 0.25. Too big. Okay, 0.2 to the exponent, what about 0.35? Closer. Let's just try one more for the sake of trying one more. 0.2 to the exponent 0.4. Wow, getting real close now. Okay, what about 0.2 to the exponent 0.43. Boom. Okay, so that just means, okay, I'm going to go back here. And that just means this is what I'm going to write. I'm now able to take, and this is a little bit tricky to wrap your head around, so just concentrate for one more second, okay? I needed the bases to match, so I needed the 1/2 here, right? And then I ultimately went to figure out what do I have to type in. Did I do this right? Maybe I did this wrong too. Sorry. That's what it is. I always make this mistake too. Okay. You need to figure out, as soon as you write it down, it makes sense. You need to figure out, in order to get the 1/2 here, you need to figure out what exponent needs to go there. So you got to do the same thing. Okay, but our numbers were backwards this time. So you got to do 0.5. I need to turn the 0.5 into a 0.2 using the same method. Okay, so 0.5 needs to get smaller. So let's go, we'll just try squared. That was actually not a bad guess. We're pretty close. Okay, so what about 0.5, the exponent of 2.5? Too big. So it's pretty close to squared, right? 2.5 was too big. So 0.5 to the exponent of 2.1. That's closer. The exponent of... Okay, we're going to use 2.3. That's pretty close. Okay, so My apologies. Let's go fix this now. Okay. You need to turn, it needs to be 1/2 to the exponent of 2.3 is equal to 1/2 of t to the 20. Now you see both sides here are 1/2. Now you can make the exponents equal to each other. So 2.3 is equal to t over 20, right? I can multiply both sides by 20. So t is going to equal to 2.3 multiplied by 20. T is going to equal, let's go back to our calculator. 2.3 multiplied by 20 is going to be 46. Okay, so therefore, okay, this was a lot. It's going to take 46 days for the radon to reach 30 grams. Okay. So, well, maybe did I type? Sorry. I did one little thing wrong here. Sorry. And normally you probably would have caught me doing this. The t value isn't 20, sorry. Or the h value. The h value is 25 days. I wrote that down wrong from the beginning. Not that it's a big deal. Okay, it just changes a little bit. Okay. Sorry. Okay, all it does here is change this. It's t over 25, right? So then your answer is just going to be 2.3 times 25. So 2.3 times 25 is 57.5. Okay. Therefore, it takes 57.5 days. Okay. That's all it changed. Okay. 57.5 days for it to reach 30 grams. Okay. Okay. I'm going to leave the last question as kind of an extra. There's not a lot going on here, except for you're going to do the same thing and try and solve for something in the exponent, I'd imagine. Okay, so the number of ants in a colony doubles every month. If there are now 600 ants, how long will it take for the number to grow to 9,600? Okay. Because I maybe because I messed up the last question, I'll actually do this one cleanly. Okay. So what you can do is it's doubling, right? So I know that the doubling equation is going to be n naught multiplied by 2 t over d for doubling. Okay, so then the end value, so the end value you want is going to be 9,600. So n is going to equal 9,600. Okay, n naught is going to be 600. Okay, and you need the number to grow. Sorry, it's going to double. So we're using the double equation, and it doubles every month. Okay, so you could say, we're going to say the d value is just going to be 1 for this question, okay, because it's every month. We're going to use, our time step is just going to be a month, okay, so our independent axis. Okay, so you're just going to plug stuff in and solve for t. Okay, and I'll try to do this a little bit cleaner, okay, so I think this question works out a little bit nicer, okay, so this would be an example of a real world example where things are a little bit more messy. This one's just strategically been picked nicely for you, okay, so to actually work out. So I'm just going to fill in the information. 9,600 is going to be equal to 600 multiplied by 2t over 1. Okay, so it's just going to become t. What you can do is divide both sides by 600, okay? So if you want to do, we can type into our calculator 9,600 divided by 600. It's going to be 16, okay? So 16. Okay, 16 is going to equal 2 to the t. Okay, now this looks very, very similar to the other day, okay? How do I get 16 from a base of 2. You got to write the base down first, right? Because you need it to be 2. You need these to match. That is no ifs, ands, or buts, no questions. It has to match in order to solve for this, okay? So for this particular question, you're asking yourself, what is this exponent going to be so that I can get 16? That is the trick, right? And it's very easy to mix this up, as you saw in the last question, is what I did, okay? So, so let's just take a look here. How many times do I have to multiply 2 by itself in order to get 16 is the question. 2 times 2 is 4, times 2 is 8, times 2, 16. So it's 4 times. So it's 2 to the power of 4 is equal to 16, okay? Now that the bases match, with the proper exponent, you can make the exponents equal. So 4 is equal to t. That is your final answer, okay? There's no more solving. And that only worked out so nicely because of the 1 that was in the for the d value, right? So, therefore, it will take four months for the ant population to reach 9,600. That's it, guys. Okay. Word problems for exponential is actually not too bad. Okay. The only tricky part can be some of the solving in the exponents, right? That can be a tricky, but again, it's just a trial and error. Okay. So, and what I'm talking about is this piece right here. Okay. This is a little bit of trial and error. That's the method that you have available to you. Okay, you're going to try that. You're going to do your best and come up with the best answer that you possibly can. Sometimes it's not going to equal perfect, okay? I'll do my best to pick a question on your summative that works out like this so I can see your skills, okay? But just know that the real world behaves like this. Not pretty, right? So, that's it. So, let me know if you have any questions. We're going to move on after this. I'm going to clump finance